3 ways to create mesmerizing motion in code. Welcome to Inside Builder channel, problem solvers, programmers, and my dear friends. Till this video, we have seen how to get the inputs, and we have also seen how to give senses to the machines using logic. After we have provided these two, you might be wondering why someone will take an input and why someone will use logic, because they want to move. See, in this world, if a machine has to move, it has to understand where it is located first of all, and it has to also see if there is any obstacles and what is its objective. I mean, it's very important, right? Why will a machine do something? Like, this is one of the important points, that is motion, to make the machine move. In order to make the machines move, the options that we have got is for loops, while loops, and yeah, you heard me right, recursion. We can use recursion also to create movement. In this discussion, we will not be introducing recursion because we have to understand what functions do. After that only we can see how recursion works. So we will concentrate on for loops and while loops in this discussion. Let's move forward. Before we jump into what for loops and while loops can do, we have to first of all think what loops itself can do. So we already have seen that loops can create a kind of a motion, right? That is for creative purpose, like machines have to just move, explore, and do stuff. But in reality, if you look at the various uh, problems that you have solved till now, you might actually think, okay, for loops are used for iterating over data, while loops are used for creating endless loops. Also, we have seen there is a way to validate the input. So we'll be seeing all these examples in couple of minutes in a code. But let us first introduce iterating over the data. So if you are given a series of numbers or a collection of key value pairs, that is someone name and their age, someone's location and their address. So if such a thing is provided, then we can iterate over those data using loops. We can execute commands in each step of the loop. We can validate the input in each step of the loop, or we can actually make the input validation endless. We can create a sequence. The data can be a sequence, that is one thing, but we can actually create a sequence. That is how we are going to create motion in couple of minutes. You will be seeing that. And we can control the code flow. So what happens is, in order for the logic to be used, so there has to be some kind of change in the environment, in the code flow. So in order to create the code flow, we need to have some kind of a loop or motion that is happening. Okay, so what we are going to do is, we are going to right now take a look at how for loops and while loops are used in the wild. We are directly going to jump into a very simple problem. It's actually not a problem. Basically, we are trying to explore and play with the scripts here. So we are going to just take a walk. You heard me right. What we are going to do is, we are going to use Python script, and we are going to let the machine, that is the Python interpreter, to take a walk. In walks, there are a couple of types of walks. So there is a simple walk, there is a forked walk, and there is an endless walk. And the code that we are going to write is going to be in an endless loop. So this is the main endless loop that we are in, meaning that once I start the code, once I execute a particular script that contains these instructions for simple, forked, and endless walk, the script will keep on asking for further choices. So in this case, we are starting at the get the walk type. So this is the starting point. We are going to start at get the walk type, and then we are going to go into any of these paths. So simple path, forked path, or endless path. If any of these paths are not selected, then the main loop is broken and the script ends. Basically, the life of the script ends. However, if any of these choices are chosen, then the particular path is executed. So in case of simple path, we next get the input, and then uh, we get the start and end positions, and then walk the walk. In case of second option, that is forked walk, we are going to get the start, end, and the fork position, at which step of the walk you want to fork. We get that information also, and then we take the fork. And finally, if someone chooses endless walk, we just walk. I mean, there is no any objective because it's an endless walk that we are going to take. However, the mission asks and stops after 100 steps. This is just to save us time. We can actually make it endless, and we can break the main loop using the interrupt, keyboard interrupt inside the Python script. But in this case, we are going to stop after 100 steps and break the main loop itself. So when I say break the main loop, what happens is whenever you are going to here, it should be break the loop. It will not be main loop. So this will just break the endless loop. It will not break the main endless loop. So keep this in mind, because when you're going to have nested loops, so we will be seeing a couple of things today. So we will be seeing a regular loop and a nested loop. So a loop within a loop is called as a nested loop. Here you see there is a main endless loop and there is a sub endless loop where we keep on walking. So these are called as endless loop. In this simple video, we have seen a lot of things. We have seen input taken by the code or the machine, and we have also seen that various logic that is going to be implemented for selecting the type of walk and then breaking from the loop. So we are going to see all these things. Before we dive into the code, there is one more question that it might arise to you. So when to visualize? So you see here I have done a lot of visualization. So I have shown you the topic, and I have shown the various types of loops that is available, and I have shown the purpose. And then here I have actually written a kind of a pseudocode, and this particular pseudocode doesn't look like a pseudocode. It looks like a flowchart, right? And this flowchart is not having any kind of fancy symbols. It's simple rectangles with letters written inside that with arrows pointing to various rectangles again, or various words. Yeah, that is all it takes to visualize the program that you're going to write. It doesn't need to be all fancy flowcharts. The flowchart or the visualization that you're going to do is for you to understand and to make your understanding more easier by putting it on a display or putting it on a paper. So this will work, but the question is when to visualize. So whether you have to visualize before writing the code or after writing the code. Okay, in this case, I had done this entire visualization after writing the code. So this is not something that we have been taught, right? We have been always taught that, okay, you have to visualize first, you have to flowchart, and then do the code. In reality, the things work different. See, after you have understood the basics of the programming language, the basics of how the syntax of the programming language works, it's always going to be going with the flow and code. This is something that I have realized after doing a lot of problems, maybe successfully and sometimes not so successfully. The idea here is that go with the flow and code first. Only when you get stuck, then start visualizing. So in my case, what had happened is I had easily started working on get the walk type, do the simple fork and the endless walk. And then I started thinking, okay, what else to do? And once I completed this fork, then I realized, okay, I can put a main endless loop on top of all this types of walks. So yeah, when you're stuck, then visualize, recollect the various strategies you can use to solve the challenge that is in front of you, and then go with the flow and code. Or else, if you are unable to solve the problem, then take help and document how the problem has been solved. So the strategy here is very, you don't need to know a lot of things here. I'm not telling that you need to go and learn data structures, go and learn some kind of new problem solving technique, and then work on the strategy and work on solving the problem. It's not That's not what I'm suggesting. You can actually try to simply visualize, uh, think about the various strategies that you know, and then solve the problem. Only when this path fails, only when you are unable to come up with new strategies, then you go and take the help and document. When you say take help, it can be from your teacher, from your friends, from your mentors, or from various YouTube videos and books. And then most important thing is you document how they have solved the problem. After that only you solve your problem, and again you have to code, you have to type the code. Fine, we have seen the process that we have followed. Now we will enter into the loop. Before we go into the code, what I'm going to do is I'm going to show you how the code works. I'm going to execute the code right now, walking the loops, and once the code is executed, there is a prompt. As you already visualized it in the software. So this is a software that we have used to visualize. This software is called as DrawIO, and this is an extension that is available in VS Code itself. There is a separate application called DrawIO also, but I prefer using DrawIO inside the VS Code as extension. As we have already completed the visualization, we will now think about the prompt. So there are three options that has been given. It's saying what kind of walk you want to take. So simple walk, walk with a fork, or endless walk. But it doesn't tell how to move forward. It is saying enter your choice below. If I don't give any choice, and if I press enter, it says okay, enter A, B, or C. Other entries will exit the script. That's interesting. Now we know what we need to enter. I'm going to press A. That's a simple walk, and it's asking, okay, give me a starting point. I'm going to say 0, and then I'm going to say 20. The moment I do that, it actually takes the walk. There is a hash which is printed for 20 times. You can count it. That's a simple walk. There is nothing involved here. We are just iterating 20 times, and we are printing, that is, we are executing a command called print the hash symbol for 20 times. Next, we are going to take the walk with a fork. So again, the inputs are very similar. I'm going to give 20, but now there is a new input that it is asking. So when you want to take the turn, I'm going to say 15. Here you see that the same walk has been executed, but after 15 hash prints, there is a turn that has happened. And after the turn, we see there is the asterisk, we see the star symbol here, which has been printed downwards. So basically there is a fork that has happened in the flow. And now comes the endless walk. So let us choose the third endless walk and see what happens. We see here that the endless walk starts, it goes straight, there is no any fork, and it's breaking after 100 steps. The reason why it is broken after 100 steps is very simple: to save time and save the amount of keyboard presses. It's as simple as that. But if you want to leave the endless walk for millions of steps, yeah, go ahead and do it. But the idea here is that we can actually create these kinds of endless walks. And then finally, we are going to break out of the script. We have seen now how the script works. And you might be thinking, okay, what problem did we solve here? See, this is the key aspect of working with code and working with machines and trying to play with it. When you take a new vehicle, say, assume that you are learning to drive a bicycle, or learning to drive a bike or a four-wheeler or a two-wheeler. What you will immediately do is you will first understand the basics of how the things work, and then you want to make the thing move, right? We all like movement. We all like to go fast and keep ourselves active, right? But have you ever wondered that how do you practice the movement in case of the four-wheeler, two-wheeler, or your bicycle? We actually move it forward, backward, apply brake, move it right, left, and do a lot of stuff when we are, when we have the basics in our hand. So the same thing we can do with programming also. Once you understand the basics of the syntax in programming, then you should be able to use the loops, the logic, to actually make the machine move forward, move backward, move up and downward, and use logic to implement all these moves without any kind of objective or problem, like this. So what happens is, when you start playing with this way of code, you don't need to actually take a walk. You can actually create circles, you can create waves using various other functions. You can work with various other mathematical constructs to create interesting uh, visuals. All are game. But the reason why we are starting with the most simplest walk is that you should be able to make the machine move forward, backward, right and left inside the command prompt. I mean, inside this command prompt. Once you are able to do that, then and only then you can go for next step. So the more easily you are able to do this with, yeah, there is mathematics involved. There is a fair deal of logic involved here. It's not straightforward, but it comes with lots and lots of practice, and it comes with lots and lots of reading others code. Believe me, when you read others code and when you see how they've implemented certain logic, then you can use that logic in your code. So these are the things that I want you guys to understand before I jump into the code actually. So uh, initially there is objective. The objective is printed. You can see the objective that gets printed here to show the movement and the direction change in the code. That's the main objective of this particular script. After that, the loop starts. So this is the main while loop, and this main while loop continuously iterates. It does not stop until you either do a keyboard interrupt, that is using Control C or Control D depending on your operating system, and or else it keeps on asking, continuing with this series of steps that is provided here. Once the loop is entered, the first command that is getting executed is the input request, what kind of walk you want to take. And then after that, the fork starts. The fork is whether the walk that is selected is having A, whether the walk input that is selected is having B, or else it is going to check whether it is going to have C. If none of these options are selected, then it tells that, okay, enter A, B, or C, or else the script will break, and this break keyword is executed, which breaks the main while loop. Okay, keep this in mind. There is a while loop here, and we will see down the line there is another one while loop inside the endless walk. So there is a loop inside the loop. Also, moreover, you will see that once you enter into walk A, let us take the fork A. In the fork A, there is again, we are going to take inputs for start and end, and then here is a for loop. So the for loop that we are going to use inside Python is going to enumerate over the range of 0, the end to start. So we are going to start with the end, which has been provided by the user. That is, in our case, it was 20 or 10 or 100, whichever number that we are going to give. And the start is usually 0. Yeah, you might actually try it with 10, 20 as a start, but the end has to be greater than the start. If you try something that is lesser than the start, it's going to be different. So try it out and see what the script does. And that is how you will learn, because we have been discussing about moving forward. So this script only shows how to move forward with the loop and move downward. But what to do if you have to move backward? and what to do if you have to do move upward. So these things is uh, actually difficult to do, and I want you guys to try it and think about it. So we have seen the for loop here. Here there is a while loop that is already occurring, and inside this there is a for loop which is a nested loop, because this for loop is nested inside this while loop. The next walk that we are going to take is the forked walk when we choose the option B. Same way, we are going to get the input for start and end, and then there is an instruction that comes in that let's make a fork in the walk. The fork input, the steps at which the fork has to be made, is also taken as an input, and then the for loop is executed, but with the internal logics where we check at which step we are in using the if condition, and then the print happens. And you will see here that in case of if the steps is less than the fork, then a regular hash symbol is printed. But if the fork is not less than if the steps is not less than the fork, then the star symbol is printed here. I'm not diving into how the print works. I'm not diving into the mathematics or kind of the logic that has been used here. I want you guys to visualize what is happening here. Okay, and also execute these things directly. Take this print statement and try to change the fork into a number and try to execute that in your Python ideally. You will understand what's going on. If you're not able to understand, then take a look at the documentation of print function. So in this way, you will be able to understand how the print function is working and how this print function has been used in this code to create the kind of fork that we are talking about. So the fork that we are talking about is like this. So I'm taking after 15 steps, I am asking it to fork down. So how this is happening and how there is a space coming here and how we are able to maintain this path, all these things we have to think about, right? These are the problems that is solved. Actually, there are a couple of problems that has been solved here, and you will realize it once you try to break apart this script. And finally, we have this endless walk. So endless walk actually has the steps counted. Even though it doesn't tell you in the script when you're executing, the steps are getting counted, and we are actually trying to print the steps also. And first time the steps get printed, but the next time it does not. So if you see the 0 here, this is the first step that gets printed. But here you don't realize why the 0 is printed until unless I come and explain it, right? And after that it starts printing the hash symbol and it goes into counting the steps, but after 100 steps have been completed. So this is how you actually break out of the while loop. In case of, as I always told, the while loop is endless. When you say while true, the loop keeps on iterating. It's never going to stop. If you actually take this particular condition, if you put it here, so while steps is less than 100, so you have to take this condition, you have to place it here, but you have to change the condition to steps less than 100. That will actually break the while loop once the steps become more than 100. And the steps are incremented in this particular function. So in this particular steps plus equal to 1, meaning this actually converts to steps equal to steps plus 1. This way of syntax is common in Python. In case of C or C++, there will be similar kind of syntax, but with the different symbols. So instead of steps plus equal to 1, it will be steps plus plus in case of C and C++ programming. In case of some other programming language, it might be different. So this is one of the ways we can actually make the movement happen in while loop, or else you will not be able to see any kind of movement in while loop. It will keep on printing, but you will not see that how to break it, or you will not see how to create a gap. So all those challenges will occur if you don't use the steps. And finally, we see that we get the input that is not C, not B, or not A. If the input is not B or not C or not A, then it exits. Simply it exits and it says break. So with this discussion, we have seen how to create mesmerizing motion in code using for and while loop. And we have seen how to create sequences using loops. And yeah, we have not seen iterate over the data. We will be looking at it down the line. We have seen how to execute commands. We have seen input validation. We have seen code control flow. All these things we have seen in this particular simple video. And also we have seen how to visualize. So it's like I wanted to create a separate video itself on using DrawIO and to visualize. Then I realized that when I started learning to visualize, I had tried various different tools. So TL Draw, DrawIO, even the simple Paint on Windows machine that is available, using PowerPoint presentations. After all this trial and error, DrawIO is one of the applications that suits and best works for visualizing for problem solving. I have already extensively used DrawIO in all my presentation till now, and I'll be using this more often as we go forward in this series of video. And you will see that even you can use DrawIO, and my presentation, it's already available in the GitHub repo. You can take a look at the link given below. The script as well as this DrawIO file also will be available in the GitHub repo. I will be sharing that also so that you guys can take a look at that. And you can try working with this DrawIO going forward. And finally, we also saw when to visualize, and if you are getting stuck, then what to do. So we have seen all this in this video. I believe that you like this video. Do leave a like, and if you like my content, do subscribe. Till the next video, where we are going to look at the functions, because that's one of the quintessential part of any programming language these days. And then we will move forward. See you guys till the next video. Have a great time.